Hey everybody, it's Dr. Mike coming to you live from the Fraxa Command Center here in beautiful West Newbury, Massachusetts. I'm going to try something new. I'm doing some videos direct to YouTube as a way of updating everybody on our progress. A few of the technical limitations that you'll notice right away. I'm going to be recording this direct to YouTube, which means we have limited editing capability. Also, I'm going to be doing the two screens thing so that I can record this on my little webcam from my netbook, while I'm also looking at my computer screen for reference, which means I need my reading glasses on so that I can switch back and forth between these things. Hopefully that's not too distracting, and I wanted to kick things off by discussing our recent Fraxa Investigators meeting, which was a huge success. It took place May 2nd through the 5th at the University of New Hampshire, Durham, New Hampshire. It's about 25 miles north of here. Beautiful campus, and they have a beautiful conference facility that they call the New England Center. Unfortunately, that beautiful conference facility is going to be closing. So this was kind of the last hurrah. We have a history of closing down conference centers, starting with our first Fraxa Investigators meeting at Arden House in New York. But hopefully we'll find another place that's just as good and hopefully just as cheap, because everybody who attended the meeting wanted to come back for the next one, and everyone was asking when and where that would be. So we're working on that right now. But just a little bit about the meeting. We kicked it off on a Sunday night with dinner, and most important part of any scientific meeting, a cocktail hour. We then had a series of presentations, and we actually had a couple of featured guests, one of whom was Dr. Kevin Moses, who's a longtime Fraxa advisor, and Kevin finally came out and talked publicly about his son with Fragile X just a little bit. Kevin's a Drosophila biologist and is also the scientific education director at Genelia Farms, which is the Howard Hughes Institute education facility in Northern Virginia. It's a beautiful place, and they recently had another Fragile X meeting there. They have to have a scientific topic other than just a disease topic, and so it's usually about something like translation of the synapse, and they usually manage to attract some really, really good scientists like Rob Singer, Eric Kandel, and people like that. Anyway, Kevin talked about how fly biology can contribute to the understanding of complex human disease like Fragile X syndrome. And I think he did a great job, because we subsequently had a number of Drosophila researchers talking about the results that they'd obtained in their work on flies, and it actually impressed quite a few of the people from drug companies who were in attendance at the meeting. We had a lot of pharma people, and I've actually had some subsequent follow-up with some of them asking about how they could do some Drosophila research as a way of testing some of their drugs. So I think Kevin got the message across, emphasized both the importance of flies as a model and basic science as something that we need to continue into the future, even as we start to do more and more clinical work. That was followed by one of our very favorite people, Will Sporen, who is a pharma researcher with Roche in Switzerland. And he talked about the efforts to develop treatments for Fragile X at a number of companies, but also talked about a new initiative that they've got going in Europe to actually broaden the base of support for this kind of research. Fragile X research and autism research is a little bit risky for drug companies, since they have to invest a lot of money, but they don't necessarily get a lot out of it. Even if you develop an orphan drug that you can sell for $50 a pill, it's not going to be the same kind of blockbuster as if you develop a treatment for Alzheimer's disease or obesity. And so they're actually developing a consortium in Europe of pharma researchers who are going to put their heads together and try to do research together in a kind of open source model, as opposed to the usual secretive, competitive way of doing things. And speaking of which, in stark contrast to Kevin Moses' presentation, Will's presentation was followed by very few presentations from pharma researchers. So we haven't gotten to that open source model of research among pharma researchers so far. And in fact, we've had quite a few people who were attending the meeting who didn't present anything at all. Some of the scientists object to that, but we know that those folks are there for a reason, and they're there to learn about Fragile X, and they're planning their strategy. So it was really important for us to have them there, and we've been continuing to plot the course for clinical research following the meeting. So I've been in contact with a number of those folks since the meeting, and things are happening. We kicked off the main plenary sessions the next day by talking about some of the major developments in research, and started off with some of the real big players in the field. We figured that was best to just get that out of the way and let these guys tell everybody what the really big labs are doing. David Nelson started off with a really great presentation where he talked about the conditional knockouts that his lab has developed. So he's got mice that can start out normally and have the Fragile X gene subsequently turned off at any point. It has a switch that's operated by administration of the drug tamoxifen, which is usually used in treatment of breast cancer. But it is very potent in this application, and so you can turn the gene off at any point after development and see what sort of phenotype you get in those animals. In other words, you can see if you turn the gene off after an animal is already 4 weeks old, which in mouse terms is kind of like an adolescent human. What kind of symptoms do you get? You can turn the gene back on if you use a different kind of switch. So they have conditional on mutations.